How's it going, people? In this video I'm going to be sharing a few results from tests with silica gel and aluminum. So over here on this first bottle, um, I had tyroline, gasoline from tires. And as you can see, the shape of the silica balls is intact. So that tells me that it did not react with the fuel. Then over here, I did have more of a powder because this is silica gel right here, desiccant. So the idea was to see if it would react, if it would remove any water, or I was hoping it would filter out the fuel, make it nice and clear like this. Now for some odd reason, this one does not light a match. Like if I'll get to that in a second. Now over here, I had plastoline, or gasoline from plastic, and it seems like it reacted with the silica a little bit because it's no longer in pellets. It's more of a powder now. See, this is what it comes. This is what I put in, and now it's like a powder, like a sludge. So I don't know if it actually sucked some of the dirt or some of the impurities, or it just reacted. I'm not too sure. But I think more importantly is this test here. So I was afraid that maybe the fuel produced would be acidic or too basic, and that would cause problems in the engine over time. So in order to test that, I put a beer can, which is made of aluminum, and the aluminum will react with any acid, or if it's too basic, it will react. So since there is no reaction, that means that the can is intact. That means that the fuel produced is not going to react or corrode the engine. This one turned like, I noticed that over time the fuels start getting darker. Some of them, not all of them, oddly enough. This here, it actually looks pretty dark, but once you pour it, it's actually relatively clear. This one came out, this is from plastic, came out pretty dark red. This was the last part of the fraction, and so it's supposedly diesel. Did I do a flame test on this one? Well, we'll do one shortly. And then over here, I've got 3 full bottles of these. Each one is 1.5 liters. So I've got about 4 liters, because they're not full all the way to the top. So I've got about 4 liters, and I think this came out more of a diesel because this does not light, does not catch on fire. Now I did look at a lot of comments from people saying that it's normal for high octane gasoline not to light, to be harder to ignite. I'm not sure that's true or not, but my reasoning is if it does not ignite outside, it probably will not ignite well inside the engine. So I'm just setting these aside, and let's do, oh yes, I forgot one other test. over here, I got sulfonic acid at 90%. And this was some gasoline from tires. And initially, it was kind of dark. And I was researching, and research suggested that sulfuric acid would react with the carbon in the fuel, carbon contamination, and it will react, and then it would separate, and it would really clear out, make the fuel transparent, since it would remove all the carbon. But unfortunately, I mixed a little bit of that sulfonic acid. Supposedly sulfonic acid works as well, according to AI, which is often full of shit. But I did mix in a little bit, and then it turned into like a mud color. And then it changed color to this more of a black, like smooth black color that you see right here. So I don't know if it has to be, I think it might have to be mixed with water. That's very pure, 90%. And then mixed with the fuel, I don't know. Or maybe I have to add some more, so I don't know, but so far it didn't work. So what I did also do is it was suggested to me that I add the acid, sulfonic acid, just a little bit, I think 1 to 5%, in the reactor. And that will lower the temperature required for pyrolysis. So that's what I did over here, but I added it to the second distillation. So because I didn't want to risk adding it to the whole thing, but we'll try adding it. So basically, adding it, you have to add it directly to the plastic. This is a plastic that I'm using. I actually got a tire processing or a plastic processing plant that's helping me out. They're supplying me with all the plastic I need, but actually 10 times more. Unfortunately, I'm just one man, and I don't have enough money yet, but this was the biggest issue, having access to the material. So you're supposed to add sulfonic acid directly to the plastic. We'll try that later. But over here, I added it to the second distillation, so this should already be gasoline coming out here. Now, I tried to scale up my operation, but this did not work, but I'll mention that in another video. Let's do a flame test with this here. This one is from tires. See, it does not light. Unfortunately, because I was hoping we could use that. Let's try, this is the last one. This is actually the first batch of plastiline that I made. What's left of it. Most of it is already in here. And I want to run the car. Actually, take her for a spin on plastiline. Let's see if this one lights. I think that one is more of a diesel. It's the last one to come out. It actually caught fire. Looks like not very well though. But I think we can mix that in with the gasoline. Having another batch coming out right now. And I think I'm not too sure, and we really have to, do a proper scientific approach to determine that for sure. But I feel like the sulfonic acid actually, this batch already has a sulfonic acid. So I do think that lower the temperature required for pyrolysis, because right now we're on minimum on the lowest flame. See, that's the highest. This is the lowest, and that's getting toasty, nice and warm. And it's actually, look at that. There's actually a lot of fuel coming up, a lot of gasoline. Well, just because I said it, it stopped. Oh, there we go. Can't see there. So, we'll see. This is just the beginning, really. So if you'd like to participate in the project, if you have results from filtering plastoline and tyrolene, please let me know in the comments.